Recording it. Okay, now done. So last time when what we discussed is how to collect the data, right? Like yesterday we discussed that how to collect the data. What are the necessary steps we need to take, we need to consider to collect the data. In that regard, we just we talked about the primary data sources. What are the primary, how to collect the primary data, and how to collect the secondary data. Right. So primary data which we collect by ourselves, secondary data which we borrow from the reliable sources. That's the difference between primary data and secondary data. There are certain fault lines. Sometimes the claims are self-proclaimed and people lie, like the researcher or the data collector. Usually the researcher assign the duty to collect the data to some new he gonna do some new hiring, then train them that how to ask and how to collect the data, and then they will go in the field to collect the data. So sometimes the participants who are there to collect the data from the field, they use their own biased methods to collect. So there can be a problem in the data reliability, especially in primary. What are the main sources? You can get the data from market, from any organization. There are certain businesses whose work is only to collect the data and to provide assistance to big um, companies for their analysis. Then by survey, by experiment or interview, and by recording the result. Then we talked about different sampling methods. So two important main methods: the non-probability sampling, where we don't assign any number, there is no probability. In all these methods, the preferences, personal preferences, are included, right? So, and in probability sampling, researcher has no biasness, right? Researcher has no biasness, and he assigns different probabilities before selecting the sampling. So in non-probability sampling, there's convenience sampling, in which we do when we are feeling convenient and we don't want to move ourselves into a lot of difficulties and not to spend a lot of resource. So we just do the convenience sampling. Judgmental sampling, an expert opinion. We know someone who is an expert about the field, and then we call that person and collect the data from him or her. Quota sampling, we already defined the ratio before collecting the data, that this much percentage is we gonna collect the data from this side and that much percent from that side. So we gonna make a ratio or a share before doing the sampling for the population for the sample n. Then snowball sampling. Snowball sampling means ask from one participant, then he will refer to another one, then he or she will refer to another one. So this is known as snowball. There can be like three kinds of snowball. One is linear, which is like one will forward us to another one. Remember one thing, snowball, we just get the data because the data points are really rare and it's really hard to get to them. It is really costly to get to them by our own. So we can take a help from the other numbers of the sample, and they can increase our sample size. So there can be three kinds of snowball sampling. One is linear sampling. The other one is exponential non-discriminative sampling, where we don't discriminate. If a person refers us to two people, we just go to two people. And there is one is discriminative. There we discriminate because of any reason. But we need to provide some justification. We need to provide some reason. So these are like major non-probability samplings. And then we talked about probability sampling, simple random sampling, where we assign the numbers and every outcome has an equal probability for being selected. Then we talk about systematic sampling. Systematic sampling where we define the order first and then we choose the outcome based on the random sampling. Like I gave the example of the classroom where we can have like 6 or 7 students in the row, and then I decided to pick the and this is not I decided because of my preference. I have to create an interval, and the interval is the capital N by small n, right? So based on that interval, I take the that position of the class, and that position will be taken. Any random outcome can be there. Then we talked about stratified sampling. Stratified sampling is like about how we have a if we have a heterogeneous population. So first we divide the heterogeneous population into homogeneous groups, means with the same traits. Then we choose from them. That's a stratified sampling. I gave an example of artists and teachers, and remember one thing, that everyone is like mutually exclusive, like means like you cannot repeat one. So a teacher should be in a teacher's group rather than an artist group, and an artist should be in an artist group rather than a teacher group. So you need to define a person. If a person is like both, like teacher and artist, then you need to see that which one is he really belongs to. If he really belongs to an artist, then you should put in an artist group. If he really belongs to teachers group, then you should put it in a teachers group. Uh, Similarly, like no single outcome should be excluded from the stratified sampling. So cluster sampling is the last one which we discussed, where we define different clusters. We make different clusters of the population and then choose the clusters randomly. Then we apply the same simple random sampling way to the cluster. Now, one thing that non-probability sampling, there are greater chances that it may misrepresent the data, right? So that's the problem with the non-probability sampling. But I'm saying it may misrepresent if you have. So you have to be very careful when you are drawing any decision to choose the sampling. Mostly, it depends what's your hypothesis, what you want to do. For means what's your analysis gonna be. So it all depends on that what kind of sampling method you should choose. Second thing, the theory, the literature will tell you that in this kind of example, if you are going to do this, you should choose this kind of sampling. So we discussed about these things. Today, we will go back. Today we will go back to measurements, because we talked about the variable data, right? There are different variables, qualitative and quantitative, and we talked about them in like our first lecture, but we didn't talk much about the measurement scale. So now from here, the numbers gonna take in. What is that? First, you should know. I will repeat like a little bit like that. You should know what is descriptive statistics. It's what we discussed, like how to collect and characterize the data, because we have the purpose to describe the data. That is what the data collection method you should choose. Now you know that, right? That what kind of data collection you should choose. In this regard, how to present, how after collecting the data, how to present the data. Can anybody tell me how to present the data? What's the basic? I already told you in the first lecture. Nobody's telling me. I thought maybe you are quick. You can tell me like quickly. Okay, nobody's telling me. Anyway, when we collect the data, the main thing we can represent the data is through tables, graphs, charts, right? Because we don't have enough time to just look at every observation, because there can be like thousands of observations, right? If you are gonna tell me, let's say in presentation, you are going to give a presentation about anything, and there you have to tell me the description of a company's performance of the annual returns or the yield of the company from 1995 to 2020. So you have two options. Either you can just repeat that in 2000. Oops. Either you can repeat in 2000. In 2000, the return was 1.3 billion RMB. In 2001 it becomes 2 point something billion. In 2003 it got back to 1.9 billion, and this and blah blah blah. Believe me, I will sleep. I'm not gonna take any interest in that kind of data, right? Which you're gonna speak by yourself, the different data points in different years. But if you present the data in a graphical way, that's how the return of that company went from 1995 to 2020. Yeah, that's enough for me. I can see that how the data moves, right? Or you can just show me in a table where you just tell the years and the data points. That's also fine with me. So I have like two major important ways to define to present the data, and that's a tabular form and graphical form. And the third form, which is included in both, that's a numerical form. That's numbers, right? So today we're gonna talk about numbers, tables, and graphs, right? But before that, we need to review a little bit about different scales and about the qualitative and quantitative. The qualitative, which is also known as attributive data, what is that? Remember, we used to present the data and characterizing. So we already talked about qualitative, but before that, just one note: what is the difference between descriptive and inferential? Just a quick review. Can you tell me what's the difference between descriptive and inferential statistics? In descriptive statistics, we try to identify what kind of information data provides us, how we define, how we describe the information through the data. And in inferential statistics, which is based on descriptive statistics, we draw a conclusion about the population. So whatever we draw conclusion for our population is inferential statistics. Remember that. So descriptive is what the data shows, what the data shows about the information, right? Inferential, it means based on this data, based on that like picture of the information, we draw a conclusion. That's it. That's a simple difference. Conclusion, or you can also say decision. We make decisions, right? So that's the main difference between descriptive and inferential analysis statistics. What is the purpose of inferential? It includes estimation. As I told you, descriptive, just you need to show with the table and everything, right? Inferential, it includes estimation. It includes estimations. Hypothesis. Hypothesis means your claim, which is not a fact yet. So you need to test your hypothesis. So main purpose, as I told you, is to draw the conclusion or to make the decision, reach a certain decision which is optimal. For example, let's say there is a factory which produces 1,000 product, 100,000. 100,000 products. Now, that's a manufacturer is producing 100,000 products, and then we have to choose 5,000 products. So we have to choose 5,000 products. Now we analyzed and got on average that 10 units from these 5,000, they are not good, means they are bad quality. Now, if our this 10 units shows that from 100,000, 200 units are of bad product, are the bad product or the defective pieces, it means that whatever our sample, our inferential, our inference, our drawing conclusion, our making decision power is correct. So that's what inferential statistics tells us, right? So we draw the conclusion for the population. So we didn't go for 100,000 products and checked each and every one. We just took 5,000 and just checked it and just draw the conclusion that our whole production could have 200. I said could have, not definitely. It could have 200 defective pieces. So this can save time and we can correct the where our factory is producing defective pieces and why. So that's the major difference between descriptive and analysis. Then we also learn once we know the type of data, that we can use certain types of methods available which we can use to analyze, which we did last day, means yesterday. But first we need to categorize the data, and the data can be categorized in two ways: attribute and variable. What is attribute? Attribute which is given. You cannot change your attributes, right? If you are a male, you are a male. You cannot change. If you are a female, you are a female. You cannot change. Okay, nowadays science can use that to change the gender, but like overall, we just say that gender cannot be changed. Once you are in one gender, most of the time you will remain there. But that's why we call it qualitative, right? So one is a qualitative data set, and the other one is a variable data, which is also quantitative data. So what's the difference? How to, in qualitative, we just categorize or classify. In qualitative, we just categorize or classify the data according to their traits. Traits means quality. For example, we can classify people on the basis of their color, right? Which is not good, but for the sake of information analysis, we can do that. That much people living in this community are white skinned, that much living in this community are black skinned and brown skinned and pale skinned, yellow skinned, right? So we can define. So what is this color? Color is a qualitative variable. Then we can also define like your name. Your names are also qualitative data because your names are different. So this qualitative data is mostly to be used for to differentiate between different variables. Similarly, you see that if we also name the city, we also name the city telephone codes differently. So these all are qualitative data. You can say, for example, in a company, we can classify the quality of products, that this one is good, this one is bad. Then second, we can have a quantitative variable. Now, quantitative variable is consisted of two further variable, which is discrete and continuous. What is discrete? Discrete, you can count, but you can't measure. Now, that's the difference between measuring and counting. So that's discrete. For example, I can count you, that there are 1, 2, 3, 4, 5, 25 students in the class. I cannot measure you. I can't say that you are there are 20.5 or 20 and a half students in my class. So I can't say that. I can't say that I drank 2 bottles. I can say I drank 2 bottles of some juice or some drinks, right? But I can't say that I bought like 2.5 bottles. I cannot buy 2.5 bottle like physical bottles. So that's the difference between discrete and continuous. Whereas in continuous, you can count as well as you can measure. For example, time, pressure, money, material feed rate. Every rate, price is also rate. Every rate is measurable. Now, time, pressure, money you can measure as like I have like 10, I have 11, I have 11 RMB, 11 yuan, and 5 mao. See, I can count within maos and jiaos. So that's how money can be calculated. Similar time can be calculated as as continuous. You can have millisecond and million micro milliseconds. So the difference between discrete, we already learned about this, that this difference between discrete and continuous are mainly based on the one is countable only and the other one is countable and measurable. Then we discussed last time about like in our first lecture how to scale them. So remember, attribute here, attribute qualitative attribute data means qualitative. For example, gender, which can be male and female. Now remember, binary is different. Binary is not related with the variable. Binary is something which is related with the value, right? So if gender is a variable, right? So it's a univariate. If I take only one, then it's a univariate. If I take 2 variables, then it bivariate. So I'm just considering one variable, and that's male and female. So this is a univariate. Its outcome is like male or female, but it doesn't mean that it's binary, right? It's not necessary. But binary is the number. When you have a value, yes and no, that's binary. And most of the qualitative data is like binary. All of it actually. So gender, it can be univariate, can also be binary. If I can take like another variable like job type, this is also binary because here we also have two outcomes like different. We can just consider 2 outcomes, right? It can be binary, it can be multi outcomes, right? It can have like managers, clerks, then CEOs of this company. So it can be more than 2 options, right? But qualitative is mostly binary. You can have yes and no, success or failure, go and no go, pass or fail. So these kind of different values. So remember that these are related with the outcomes, not with the variable. What is the outcome of that variable? Like you go, now you are a univariate variable. You are male or female, right? Now you can go, you can leave the class or you can join the class. You have 2 options, right? Right now you can listen to me or you cannot listen to me. You have 2 options. These values, these outcomes are the binary. Hope you have understood this. Right. So we discussed about nominal, ordinal, interval, and ratio scale. What is nominal scale? To classify what is nominal scale? Now we are talking about different. Now we are talking about different scales: ordinal, nominal, interval, and ratio. Just to repeat, like the first lecture's information, which I shared with you, that nominal just classify, they just make difference. It doesn't tell you anything else, like which one is better, which one is not, which one you should choose, which one you shouldn't. You just know that you're different than the other. One outcome is different than another. One variable is different than another variable. For example, you are different than another student, right? You have different student ID. He or she has different student ID. So that's nominal. It just differentiates the data. And it's a type of qualitative. So these two are the qualitative data, and these two are quantitative, right? And this is qualitative. What is interval? Interval scale, as I told you last time, that here the interval is given, right? You can be having like different interval from 20 to 30. I give you example of temperature, right? So high temperature is 22 and low temperature is -5, for example. So this is the temperature in degrees Celsius. So in this range, you can have, what's the difference? What's the main thing? Here, the zero is having meanings. The zero is meaningful. Like if you have a 0 degree temperature, it doesn't mean that it's nothing. It means that there is temperature, right? Which is zero. You cannot say that it's nothing. It's meaningless. It has meaning. So that's the difference between interval and ratio. Interval differences, but no absolute zero. There is a zero, but it should have some meaning. Ratio is means where zero doesn't exist, which is absolute zero. How to draw these measurements types mathematically? You can say that nominal can have equal or not equal. Ordinal, we can also give rank, which is greater and less. So if we categorize, this is categorization and recognize and ranking. This is categorization, and this can give you the sign that plus or minus, and here zero has some meaning. Ratio is just a ratio. It can be any number, but it should be zero. For example, when the speed is zero, it means nothing, right? You are static. You are standing at one point. Similarly, when the pressure is zero, it also means that you are standing at one point. That means you're not having feeling any pressure. Now, let's say how to analyze the data. As I told you, we can analyze the data, but before that, we need to present the data. So how to describe the analysis of qualitative. Yeah, qualitative data. Now, we can show the qualitative data with tables, graphs, and numbers. When we talk about table, there can be different kinds of table: one-way table, two-way table, and n-way table. Let me show you here one thing. Where are we? Yeah, here. Oops, sorry. Here we go. How to do that? How to do that? How to do that? I think, I hope, yeah, I got it. So let's say, what is one-way table? One-way table means if we consider only one factor to explain why. For example, we can have a certain set of data about different employees. I don't know why it gets stuck. Anyway, we can have employees data, and we can have different variable there. But if we take only one variable, that is just gender, education, or educate, we can have different variables, right? Gender, education of employees, and many more, right? Health of the employee. Let's escape to cancel. Okay, I don't want to do that. I can to cancel it. Not working. Ah. So if we consider one variable only at one time, then it's a univariate one-way table. Then we have to show it one-way table. Okay, I got it now. So, for example, how Let's say we have a table frequency, sorry, tables with one way. Why it's not working? Now, the one-way table, we can just draw in a simple way. So this is our table. We have only one variable, that's gender. And we divide it into two, either male or female. This is one-way table. Now, if we consider more than one variable, then we have to draw a two-way variable. Let's say add the same thing, add the job variable, or yeah, job variable. So now we have gender, male and female. So if I draw this in such a way that I can get, so that's gender. I have in gender I have male and female, two categories, right? Let me draw again. So now this is gender. I will just show with the G or gender. I have male, I have female. Now here I have another variable. I consider jobs, and it also have like two outcome. One is a manager level job, right? That's manager, and the other one is like low level or clerk level job. Now here, now this is a two-way variable, right? A two-way table, right? Similarly, we can go further. We can also add here different variables, right? So it can be three-way variable, like you can add here, let's say marital status, which is married or single, right? You can add more. So main categorization is qualitatively with male and female, and then you can add other qualitative variables. So until n, let's say you have n variables, so it's gonna be known as n ways table. So there can be different ways of table. It depends what you want to study. Right, so it can one-way table. Now you know how to do in a qualitative data set, and two-way tables and n-way table. You just present the data in such a way. Then it's about, but you can present the same data with a bar chart, pie chart, multiple bar chart, component bar chart. What is bar chart? To compare. When we need to compare two different qualities, we just use bar chart. So pie chart, you just show the share, right? Similarly, you can use multiple bar chart. Multiple bar chart means you can draw like bar chart like this, one about one variable and then about another variable. So this is going to be multiple bar chart. And percentage, you define numbers here and the percentage, that how many males, like you can say 62% males, right? So that's how you present the qualitative data. Now let's talk about quantitative data. Right? Okay, this is quantitative data, not qualitative. Quantitative data. So in quantitative data, first let's discuss about tables, how to draw tables here. So we have two ways to draw a table. That's frequency distribution and stem and leaf plot or stem and leaf distribution. Graphical, we use histogram to present the frequency distribution, and we also use dot plot and box and whisker. We also use means stem and leaf itself. Some people can use it as a table. Some people say that no, it's a plot, right? So, but most of the researchers take it as a table form, right? And then will talk about numbers, that how the numbers will be presented or collected after collection. So there are four important points. One is like central tendency. What are the center of those data set? Important points. What are the important points? So up till this, we're gonna learn today. And then a variation and distribution we will talk in our next lesson according and along with next topics. So right now, I think we can take a break for 9 minutes, and then I will see you at 9 o'clock. Okay, so enjoy your break. And don't talk anything about statistics during the break. Okay, and you can ask me questions during the break and I will answer them. So let's have a nice break.